Ocean plastic has become one of the most urgent environmental challenges of our time, drifting through currents, washing up on beaches, breaking down into microplastics, and threatening marine life across the globe. But behind the effort to reclaim this waste is a rapidly growing industrial recycling system. One built on coastal cleanup operations, floating collection devices, shredders, friction washers, chemical purification tanks, and extrusion lines that turn dirty, sun-bleached, salt-covered plastic into usable pellets for new products. And today on the How Factory, we're going inside that system to see how ocean plastic is collected, cleaned, sorted, melted, purified, extruded, and transformed into new raw material. What looks like trash pulled from the water is actually the beginning of a high-tech recycling chain, engineered to give discarded plastic a second life. The journey begins in coastal communities, river mouths, and open ocean cleanup zones. Depending on the collection method, ocean plastic arrives in vastly different forms. Tangled fishing nets, broken crates, rope, fragments of bottles, microplastic flakes, sand-filled containers, and debris weathered by years of UV exposure. Cleanup organizations use skimmer boats, trawl nets, floating barriers, conveyor barges, and specialized interceptors positioned at river mouths, where most plastic enters the ocean. Volunteers and workers on beaches collect material by hand, filling bags that are then transported to sorting hubs. What all this material has in common is extreme contamination. Salt, sand, algae, marine organisms, biofilm, mud, and organic waste cling to every surface. None of it can be recycled until it undergoes intensive cleaning. At coastal sorting stations, workers and automated systems begin the first separation. Large debris, like nets and ropes, is cut down using industrial shears. Nets, often made of nylon or polyethylene, are valuable but difficult to handle because they are tangled and full of organic matter. Sorting tables equipped with conveyor belts allow workers to manually remove wood, seaweed, shells, and non-plastic debris. Metal detectors and magnets remove hooks, nails, and fishing gear. The plastic is then hand-sorted or scanned using optical identification systems that recognize types of plastic based on color and infrared reflectivity. This step is vital because each polymer must be processed differently. PET bottles cannot be recycled with polypropylene fishing gear or HDPE detergent bottle fragments. Once sorted, the plastic is packed into crates or bales and sent to specialized recycling facilities. Upon arrival at the recycling plant, ocean plastic moves into the pre-washing zone. Here, large rotating trommel drums rinse off sand, stones, and surface contamination using high-pressure freshwater jets. These drums look like giant rotating cylinders with perforated walls that allow sand and small debris to fall through while the plastic passes onward. Because ocean plastic often contains biological contamination, many facilities use sanitizing additives, heated water, or enzymatic cleaners during pre-wash. The goal is not to fully clean the plastic yet, but to remove the worst of the contaminants so downstream machinery doesn't become clogged or damaged. Next, the semi-cleaned plastic travels to shredders. Industrial shredders tear the material into flakes using rotating steel knives. Fishing nets and ropes are notoriously tough, so the shredders use high-torque motors and hardened blades. As the plastic pieces break down into uniform flakes, conveyor systems transport them to a friction washer, a machine that uses spinning paddles or high-speed rotating cylinders to scrub flakes against one another. Water continuously flows through the washer, flushing away algae, organic matter, and dirt loosened by friction. The flakes emerge cleaner but still not pure enough for manufacturing. After friction washing, the plastic enters flotation tanks, long water-filled basins where materials separate by density. In these tanks, lighter plastics like polyethylene and polypropylene float, while heavier plastics like PET sink. This step helps separate mixed streams that escaped earlier sorting. Air bubbling systems keep the mixture agitated so contaminants detach and float away. Workers or automated gates skim off floating plastic while heavier materials settle to the bottom for collection. Oil water separators remove any marine oils or petroleum residues introduced during collection. Once separated, the plastic travels to hot wash systems. Hot washing is one of the most important stages in processing ocean plastic. Flakes enter large stainless steel wash tanks filled with heated water and environmentally safe detergents. Mechanical agitators churn the mixture, scrubbing away remaining organic residue, salt crystals, sunscreen oils, and microscopic biofilm layers. Because ocean plastic often contains microorganisms, the water may reach temperatures high enough to disinfect the batch. After the hot wash, the plastic enters rinse stations that spray it with clean water until detergent is fully removed. Filtration systems reclaim and treat spent wash water, so the facility minimizes environmental impact. Now thoroughly washed, the flakes must be dried. Centrifugal dryers spin the material at high speeds, flinging moisture away through perforated walls. Heated air streams finish the drying process in fluid bed dryers, machines that blow hot air upward to suspend and dry flakes evenly. Moisture content must be extremely low because even small amounts of water can cause defects during melting and extrusion. Once dry, the plastic is ready for the next stage: purification and extrusion. Extrusion is where ocean plastic becomes new raw material. Flakes move into an extruder, a heated barrel containing a rotating screw that pushes the plastic forward while melting it. The extruder gradually increases temperature and pressure until the plastic melts into a thick, viscous liquid. But ocean plastic often contains impurities even after multiple washes, so the molten stream must be filtered. Melt filters, or screen changers, equipped with fine mesh screens and self-cleaning systems, strain out remaining contaminants like microdebris, sand, or degraded plastic fragments. Some advanced systems use laser-drilled metal plates with microscopic holes that remove the smallest impurities. To improve quality further, many facilities use degassing zones in the extruder. These zones create vacuum pockets that pull out volatile compounds, odor molecules, moisture vapor, and degradation byproducts that ocean plastic collects while floating in salt water and sunlight. Without degassing, pellets would smell bad, discolor, or fail quality requirements. After purification, the molten plastic flows through a die that shapes it into long strands. These strands fall into a water bath that cools and hardens them instantly. The solidified strands then pass into a pelletizer, a machine that chops them into small, uniform pellets known as nurdles. These pellets are the raw material used in manufacturing new products. Pellets are screened to ensure uniform size and collected in large bags or silos. At this point, the recycled ocean plastic has gone from trash floating at sea to a fully refined industrial feedstock ready for reuse. But the journey doesn't end with pellets. Quality testing continues. Labs evaluate each batch for melt flow index, tensile strength, color consistency, density, and contaminant levels. Because ocean plastic often degrades due to UV exposure, quality control teams measure polymer chain length and oxidation markers to determine whether additives are needed. Stabilizers, colorants, or compatibilizers may be mixed into the pellets to improve durability or match manufacturing requirements. Once approved, the pellets move into the packaging station. Large sacks known as super sacks hold hundreds of kilograms of material, while smaller facilities may fill drums or bags. Automated sealing machines close each sack and attach printed labels with batch numbers, polymer type, and origin data. Palletizers stack the sacks, wrap them tightly, and stage them for shipping. Manufacturers use ocean plastic pellets in a wide variety of products. Some brands create clothing fibers, shoes, phone cases, packaging, detergent bottles, or even new fishing gear made from recycled nets. Others blend ocean plastic pellets with virgin plastic to produce stronger, more consistent materials. Industrial extruders, injection molding machines, or fiber spinning lines turn these pellets into new goods that re-enter the global supply chain. In some cases, traceability systems allow brands to identify which coastal region or cleanup mission contributed plastic to a specific batch. Behind the scenes, the logistics of recycling ocean plastic are enormous. Collection teams coordinate with recycling plants across continents. Sorting facilities track polymer types and contamination levels. Transport trucks haul bales to washing plants. Water filtration systems capture debris and treat wastewater before release. Energy-efficient dryers, green chemistry detergents, and heat recovery systems help reduce environmental impact. Even the waste, shells, seaweed, sediment, and non-recyclable plastic, must be processed responsibly. Many plants convert organic residue into biogas or compost and send unusable plastic to waste-to-energy facilities. What makes ocean plastic recycling remarkable is how it transforms one of the world's most persistent pollutants into a usable manufacturing resource. The process combines marine cleanup efforts, chemical engineering, mechanical recycling, environmental science, and high-speed industrial automation. Every flake of ocean plastic captured and recycled represents less waste in the environment, fewer marine animals harmed, and fewer tons of virgin plastic produced from petroleum. And that is exactly how ocean plastic is collected: sorted, shredded, washed, hot cleaned, separated, dried, melted, filtered, degassed, extruded, pelletized, and shipped back into the global manufacturing cycle. A powerful example of engineering and environmental innovation working together to turn pollution into possibility. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the factories and systems behind everyday products.